This is 2024 AP Physics2 FRQ. A circuit consists of an ideal battery of EMF E and four identical resistors R1, R2, R3, and R4, each of resistance R as shown in figure 1. For parts A1 and A2, express your answers in terms of numerical values E and R only. Derive an expression for the current I1 in resistor R1. 2. Derive an expression for the current I3 in R3. B. The partially completed bar chart in figure 2 shows a bar that represents the absolute value of delta V of the potential difference across the ideal battery. In figure 2, draw a bar to represent delta V across each resistor relative to the EMF E of the ideal battery. The height of each bar should be proportional to the value of delta V represented by that bar. If delta V is 0, write a 0 in that column. Next, a student claims that the rate at which energy is dissipated by the circuit can be expressed as P is equal to 3E square over 5R. State whether the expression for P is correct or incorrect. Justify your answer by referring to the derivations from part A or the bar chart from part B. When ideal battery is connected in the original circuit, the rate at which energy is dissipated by resistor R is P original. The ideal battery is now replaced with a non-ideal battery of EMF E and internal resistance R to form the new circuit shown in figure 3. The rate at which energy is dissipated by resistor R1 in the new circuit is P nu. Indicate whether P nu is greater than, less than, or equal to P original. Briefly justify your answer. This question is based on Ohm's law. Okay. Now let us try to solve this question. This is a combination circuit. Why I am saying that it is a combination circuit? The resistances are connected in series and parallel with the supply voltage. Okay. So this is the supply, and then these are the resistors. Each resistor has the same resistance R. Now we have to find out the effective resistance of the circuit. Now let us find out that this is here. You see R3, R4 are in series, and then the effective resistance is in parallel with the R2. So therefore, the effective resistance of R3, R4 is 2R, and then 2R is parallel with R. Therefore, the effective resistance of R3, R4, R2 is 2 by 3R. Now this 2 by 3R is in series with R1. Therefore, effective resistance of the circuit is R plus 2 by 3R. That is equal to 5 by 3R. Now we have to find out the current flowing through R1 and current flowing through R3. Current flowing through R1, to find out the current flowing through R1, if we find out the current flowing through the circuit, that itself is the current flowing through the R1, because the current entering into the circuit through R1. Okay, whatever the current flows through the circuit, the same current flows through the R1. So therefore, we have to take the effective resistance, and then we know, according to Ohm's law, E is equal to IR. Therefore, I is equal to E by R. Therefore, here I1 is equal to, here E is, voltage is E, am I right? And then the resistance is 5 by 3R. Therefore, I1 is equal to 3E by 5R. Okay, this is the current flowing through the circuit. The same is the current flowing through the resistor R1. Now, we have to find out the current flowing through R3. To find out the current flowing through R3, what we do is, we know I is equal to V by R. Am I right? So we will find out the effective voltage at the junction, and then that divided by the resistance of R3 gives the answer. Okay, now what is the voltage at R1? Voltage at R1 is this one, IR. Am I right? Voltage is equal to IR, no, current times resistance. So we already found out the current, and then resistance at R1 is equal to R. Therefore, voltage at R1 is equal to 3E by 5. The voltage of the supply is E. Therefore, E minus 3E by 5 gives the voltage at the junction. So that is when I found out the voltage at the junction. This is the voltage at this one, okay, R1. And then now we have to find out the voltage at the junction. Voltage at the junction is equal to E minus 3E by 5. That is equal to 2E by 5. Now current at the junction. What is the current at the junction? Current is equal to voltage by resistance. Am I right? And the voltage is 2 by 5 E, and then the resistance is 2 by 3 R here. The junction equivalent resistance is this, no? So putting that one, the current is this one. Okay. 3E by 5R is the current at the junction. Now, what is the current at R3? This current is divided by among the three resistors. All the three resistors have the same resistance. Therefore, this divided by 3 gives the current at the resistor R3. So, current at the resistor R3, I3 is equal to E by 5R. The same thing I wrote here. Now, he is asking us to draw the voltage drop at every point. That means at the battery, at R1, and at R2, R3, R4. Now at the battery, we know it is E, and at R1, here R1, it is 3. Am I right? See, 3, see here, it is 3 by 3E by 5. So 3, this is voltage drop is 3 lines we have to draw. And at R2, we have to draw 2 lines. This one, okay, junction. And then R3, R4, 1, 1. Like this is the answer for this one. And then next, power. He's asking us to find out the power. Actually, the student gave the power value. We have to check whether it is the correct or not. So we know power is equal to current times voltage. And current is equal to voltage by resistance. Here voltage is E, and then the resistance is 5 by 3 R, effective resistance of the circuit. Therefore, P is equal to V square over R, because I is equal to V by R. No, so if we substitute here, V square over R, P is equal to V square over R. Here V is E, therefore E square over R is equal to 5 by 3 R. Therefore, 3 E square by 5 R is the power of the circuit, which is correct. This is what the student gave. Therefore, P is correct. His answer is correct. Next, the circuit, in the circuit, the battery is replaced by the non-ideal battery. For an ideal battery, the internal resistance is equal to 0 or negligible. But non-ideal battery, the internal resistance is effective. Okay. So therefore, he replaced an ideal battery with a non-ideal battery. Therefore, the resistance of the circuit becomes more. Am I right? Compared to the original resistance, now the resistance will be more by a factor R. We know power is equal to V square over R. When R is more, then what happens to the power? The power decreases. Am I right? Here, that is what I wrote. P nu is less than P original because R nu is greater than R original by a factor R. Therefore, P nu is less than P original. So this is the justification and this is the answer. Okay. So hope this helps. Thank you. Bye bye.